Okay. Hi, everyone. I'm Gurman. I'm a data engineering fellow at ERD in the Census Bureau. I'm a rising senior at UCSD, and right now the title of our project is Raiders of the Lost Archives, expanding access to historical criminal justice data.
Hi, everyone. My name is Chanteria. I am Gurman's partner on this project this summer. I'm also a data engineering fellow this summer with the U.S. Census Bureau, and I'm also a master's student at the University of Chicago studying public policy and computer science. This summer, our supervisor was Liz Wilhide, who is the chief of the U.S. Census's Criminal Justice Branch, and our technical advisor was Claire Spear, who was a Civic Digital Fellow last summer and whose project we built upon this summer. So first, I'm going to start with a little bit of background about our project. This summer, our project was on behalf of the Criminal Justice Employment and Expenditure Series, or CJE&E. The CJE&E is an extract series sponsored by the Bureau of Justice Statistics, and it draws its data from the Census of Governments and annual related surveys. This series allows access to historical and current criminal justice data for a variety of data users. For one, the data we provide to BJS allows policy researchers to understand the impact of different sectors of the criminal justice system on the United States. This can be demonstrated by the research article emphasizing the impact of jail spending on the US. Although the CJE&E data is already publicly available, it exists in inaccessible formats across a variety of federal platforms. In an effort to centralize access to this data, the Bureau of Justice Statistics has developed the Justice Expenditure and Employment Data Tool, or the JEET tool. This tool provides visualizations for CJE&E data, and this tool is currently live on the BJS website. The video shows a sample of the types of visualizations the tool includes. Over the last 3 years, Census and BJS have worked to convert static data files into a new format that can be uploaded into this tool to expand the robustness of the data available through the tool. And with the introduction of this tool, the Bureau of Justice Statistics has asked Census to provide data from 1982 onward to show long-term changes in criminal justice data that users can access more easily, a task that was started by Claire last summer and which we have continued this summer. So the historical and current data available through the JEET data tool includes employment and expenditure data for 3 justice-related functions. These functions include corrections, which are activities such as probation and parole, judicial and legal, which are activities like courts, sentencing, and public defense, and also police protection activities. Within the 3 justice-related functions, Census provides data to the Bureau of Justice Statistics on 2 separate levels, and this is on the individual and on the aggregate level. In terms of the individual units, this includes data from all 50 states and cities and counties that meet specific population thresholds. Alternatively, the aggregate units includes data on the federal, state, and local government level. With this data, we provide annual data outputs to BJS that includes current year data and data from the previous 2 years. However, there is a problem with the way we are able to provide data outputs to BJS. As mentioned before, to further build out the Justice Expenditure tool, BJS wants us to migrate historical employment data from 1982 to the present. Yet this data exists in a variety of disparate formats, and these formats can include Excel files, CSV files, text files, and these data types can include a significant amount of missing data, which we would need to calculate from the data that is present in the disparate files. Because of this, one of our goals this summer was a continuation of last year's project to standardize these formats into a central database to allow easy access to over 40 years of historical data. More specifically, our summer goals were broken down into immediate and then more long-term goals. For our immediate goals, given that our primary goal was this delivery to the Bureau of Justice Statistics, it was important to migrate all the historical data and create commands for easily developing data output scripts. In addition to this goal, our work aimed to make the process of migrating future data and generating annual data outputs to BJS in the future more streamlined by developing a user-friendly data migration tool. Not only would this tool lead to the reduction of manual error when trying to input this data, it would also prevent individuals who may be unfamiliar with our Python script from having to go into the raw code in order to generate these outputs for the Bureau of Justice Statistics. In terms of our long-term goals, given that criminal justice statistics is a subset of the data Census works on, our long-term goals were centered around making the code we use this summer scalable to larger future projects. And we wanted to ensure this by developing code and application documentation standards that would allow individuals who may be unfamiliar with the CJE&E project to easily go into our script and adapt it to their own project. In addition to this, we wanted to create in-depth instructions for editing and manipulating the front-end tool to, again, allow individuals unfamiliar with the CJE&E data or criminal justice data in general to adapt it to their own projects.
And then up next, we have the database schema. So this schema was created by last year's CDF. And with this database, we collected the disparate data about criminal justice activity and supplemental data for the different types of government and put them into a central and accessible location. And then our general steps. As Chanteria mentioned at the beginning, we started out with a lot of fragmented files and missing data. Liz, our supervisor, identified and grouped these files together based on their similarities, and they wrote instructions for each data type using GitLab. Then using Python and SQL, we created classes to take the raw data, do the calculations, supplement them with the other tables, and then migrate them over to the database in a standard table format. And then all of these files and this code was linked to our Flask app, which pretty much allows other people in the Census Bureau to upload a raw data file that matches one of our types and have it be inputted inside the database without having to do any coding. And here is a quick demonstration of our Flask app. So as you can see, first what you do is that you select the kind of data that you want to migrate. Then you input the year of the raw file because most of our raw files are annual files. Then you put the vintage, which is the current year. Then you upload your raw file, which usually doesn't have any pre-processing done to it. Submit all of your information. And over here, you get a little warning message that technically for this data type and vintage and year, you've already uploaded these records. And if you do it again, you would essentially be overwriting the pre-existing data. But for the sake of this demonstration, we'll run through it one more time. And first we verify all of our information. And then we pretty much scroll through our raw data to make sure that this is the exact data that we want to migrate and manipulate. Once we confirm everything, it's been migrated, and we can see the success message, and that once again confirms the year and vintage and type. And we can also see exactly how many records were updated or inserted into which kind of tables inside the database. And then finally, we can scroll through what a snapshot of what the table looks like after it's been manipulated inside of the database. And then moving on to project impact. Over the last 2 project cycles, since this project was continued, we've kept track of these metrics through GitLab. So first, we started off with about 79 raw large data files. We created about 22 classes for each data type in total. We inserted about 120,000 records, updated 40,000 records, and then resolved around 50 issues in total. At the end of the day, we migrated about 70 plus years during our projects, saving and automating about two weeks of work annually. Previously, our supervisor spent the 2 weeks manually working in Access and running repetitive queries separately. Our work also significantly mitigates human error because it eliminates the need for logical testing only at the end. And in general, we also allow the team to spend more time on expanded analysis and other special research topics. And then preparing for the future. Chanteria and I went beyond our core goal of just migrating historical data inside the database by adding a lot of features that pretty much stand against the future and meet our long-term goals. We have 3 main categories of features, and the Venn diagram shows their overlapping nature. First, robust testing. A lot of our files had missing pieces of the larger table, and the majority of our work was pretty much calculating and deriving the different rows and columns needed to make a full table. The complexity of these files pretty much caused us to implement tests along the way instead of waiting until the end. We also created standardized testing frameworks, which made testing more efficient for us on this project, but it also lays the groundwork for future coders that come onto this project. Then we added Flask app features that we showed a couple of slides ago that pretty much allow more transparency and ease of use for the end user. And then we have some code aggregation. The code aggregation is essentially a simplified coding structure that accounts for the similarities across different data types. This code aggregation also means that in the future, if people want to add more data types, they can essentially reuse our code but change the way the data is pre-processed, and that data could also be then uploaded into the Flask app. We also created a lot of documentation, including the Git command guide, the general coding guidelines, and an introduction to the database. And all of this helps our project persist after our fellowship. Thank you for listening, and let us know if you have any questions.
have a question, just a curiosity question. How are you guys able to like standardize across so many different data types with like, I'm sure tons of different like types of errors and like, I mean, I know cleaning data is not fun, so I'm just curious how you were able to do it from so many different sources and like get it all together. If it was like individualized or more kind of general approach.
Yeah, I can start off. So even within like all the different types of data, Chanteria and I divided up our work. So we took like two different extremes of the different like files available. And throughout that, I think the way we both approached it was to create as many functions and generalize them as much as possible. So whatever structure that we could find, we could try to reuse the same functions.
Yeah, with that, since this is governmental data, the codes that represent different governments don't change that often. Like there are state FIPS code that like the US hasn't added a new state in a few years. So like those won't change that often. And many of these codes still exist in these different data types. So when Claire was making the database last year, she standardized tables that like kept track of all these governmental codes. And more likely than not, the data types that we were migrating have at least one of these codes that we were able to use to like input into these like standardized functions that we made and then migrate into the database.
That's super cool. Thanks.
This is Jordan. I think you're doing great work. The difficulty of going across different data sets is certainly not to be ignored. I'm curious though if that was the more difficult part, or what you felt was the most difficult part of the fellowship in general, not necessarily the technology part, because I know that there's lots of different aspects of working in government that can be pose challenges. So what was the most challenging part of this?
I can start actually. So first start by not answering your question in that our team definitely wasn't challenging. Our team was amazing. There was two of us and then we had Claire and Liz and we worked really well together. I think the fact that we worked really well together caused some of our challenges, one of which being me and Gurman were both trying to work on a database at the same time. So we always had to like schedule when we were going to do migrations, because if one of us did a migration and the other one is like working from an old database, like it would result in like incorrect records or like records that just have a lot of null values. So we had to like organize how to do those migrations by using Git and GitLab, if you're familiar with that. And also just like creating a lot of schedules and having a lot of communication. And even then, even this morning, our like migrations broke. So we had to like completely reclone the database for our supervisor in order to like get over that.
I'll follow up on that. Exactly the same thing. Like initially, I guess like when you meet with another fellow, I never thought that we have to mess each other like a dozen times a day almost, especially towards the end when we were doing the migrations to pretty much schedule exactly when we're pushing different things. But I think the most challenging part for both of us at the beginning was getting familiar with the database, because even though we have the schema now, it wasn't necessarily as organized when we were starting. And I think just organizing the different issues, instructions, and like understanding where things are supposed to go is definitely a bit of a learning curve.
Any more questions? If not, we can also talk a little bit about like the impact that our supervisor has said our project has put on her. Like Gurman mentioned this during the presentation, but we saved our supervisor a ton of time because in the past, she was using Microsoft Access, which is a database platform, to do all of these migrations. And she was the only person on the CJE&E project and had just been bringing fellows on during the summer. So last summer when Claire created the database, like that was revolutionary for her, and she's not familiar with like Python and SQL, but Claire was able to work with her to like create these different commands that she could easily use to develop these scripts. And then this summer, Gurman and I were able to come on to like finish the work that Claire was doing and essentially completely automate the tasks that our supervisor was doing, which is great because our supervisor was just promoted to being the chief of the branch while still like working on this project. So we were able to almost completely take this project off of her hands. And Gurman and I in the last week, which is not in the presentation, are also working on different web scraping algorithms that we could also use so that she doesn't have to manually download these files from different websites and upload them to the database. They can just be automatically migrated every year.